So I think the title has already been mentioned, so I'll just move right on. Okay, so I thought about, after listening to lots of great talks over the past few days, what was it that I really had to say to this audience as part of this conversation? I really like to think of things like lectures or scientific articles or even novels. Even though we think of these as being non-interactive, the truth is that from a sociolinguistic perspective, we think of all communication as being interactive. And so although you might think that a lecture is sort of the ultimate in a non-interactive format, in fact, I'd like you to consider this a contribution to an ongoing conversation. And I've been thinking to myself, as we've talked a lot about how we can improve education, that one of the things that I think is a danger, I don't think it was something anyone intended to communicate, and yet sometimes I think we can start to get into a mindset where we think that what would be the best possible outcome would be to maximize efficiency, that a student sitting at a computer can get everything that they need, that it knows exactly how information needs to be delivered to that student, what activities that student needs to do in order to learn, and get them to a skill level that they need to reach as efficiently as possible. And of course, with a lot of the pressures that we all face, that is a value. It is something that we have to seriously consider. But I'd like to say that I think that none of us would like a future where what we give to our children is the experience that they go into a room by themselves, sit down at a computer, get that knowledge and skill that they need, and come out. Because the truth is that we all interact in a world where we have to work together. And that's becoming true more and more and more. And there are two big reasons for that, one of which is we can accomplish more when we build bridges, when we interact, when we work together. But it's also more enriching for us as humans, that part of our human experience is to benefit from our interactions with each other. So I'd like you to take from this conversation, my lecture, the idea that the ultimate in personalized instruction would respect the social angle as well, that relationships are critical. So I'm going to talk a lot about how students benefit from their interactions with each other, but also that we have to pay attention to social factors in orchestrating those interactions between students, because students will benefit more from their interactions with certain students who they have some respect for, that they're interested in, that they get along with. Now, of course, we can't live in a world where we only interact with those people who we naturally gravitate towards, but in the short run, if we want a situation to work out maximally beneficial, we should leverage a good social interaction. We should foster a positive social environment. I'm going to talk about bringing together cognitive factors and social factors in learning, and that theme is going to come up over and over in what I'm going to talk about today. And since we have some other fellow computational linguists in the audience, I'd like to point out that ideas about how to bring together theory and computation in the area of analyzing discourse is more and more popular in the language technologies field in what can be called computational social science or computational sociolinguistics. It's been mentioned under various names, and in the past year in our main journal, there has been a survey article, which I had the privilege to be part of putting together, that really summarizes work in this area, but also takes a very critical look at it and how the field could benefit more from intensive collaboration between the computational and the behavioral. So I just want to point to that article because I think it really is brings together a lot of ideas that this workshop also is bringing together. I'm going to focus on a property of interaction called transactivity, and anyone who's heard a previous talk of mine probably heard me mention that word because my group has focused a lot on analyzing this property of discourse from multiple angles, encouraging more of it in interactions with students towards increasing learning and success in the interactions. But here I'm going to talk about it from a different angle, how it is that you can get a read on the social environment in a collaborative group from looking at this property of discourse. If you've never been in any of my previous talks, you might not have ever heard that word before, and you might not know what it means. So very simply, it's the idea of students building reasoning together, making their mental models public and explicit in how they express their ideas, and connecting their expression of their mental models with the expressed reasoning of other students or other people in the interaction. And I'm going to talk about what's behind this idea that brings together the cognitive and the social. It's that students need to feel safe in an interaction in order to make their mental models explicit. Otherwise, they might be more inclined to say as little as possible or not reveal the inner workings of their minds. But if they want to reach out and interact with one another, they will be more likely to actually make that reasoning explicit. And if they're interested in the reasoning of others, they will show that they're thinking about it behind the scenes. How what they think connects up with the thinking of others, and also that their orientation is towards coming to a way of understanding their ideas in the context of the ideas of the group by making those connections explicit in the discourse. So here's an example of a transactive exchange between students. It comes out of a study that I'll talk about a little bit later. For 3 or 4 years, I worked very closely with Lauren Resnick at the Institute for Learning at the University of Pittsburgh, who has for a long time worked in classrooms to encourage teachers to use practices called accountable talk facilitation moves in order to encourage students to behave transactively with one another, to articulate their reasoning and build reasoning on reasoning. And in that context, we worked in 9th grade biology in an urban school district. And here's just an example of an exchange in one of the kinds of collaborative experiences we developed together where students were working on ideas related to genetics. And here one student is, they're looking at cats reproducing, and could you make a prediction about the color of the children cats from parents, and how would you explain the connection? And the first student is talking about how they would explain the result of 2 cats coming together, what were the factors involved. And the second student is agreeing and explaining why they agree. Now, there are lots of different kinds of transactive exchanges between students with different properties. They don't have to agree. They can strongly disagree with one another. But the key point is that they show that connection and that they're evaluating how their reasoning lines up with that of another. It requires a lot of effort on both sides. So in today's talk, I'm going to first give kind of an overview of the technology for supporting team-based learning that my group has developed over especially the past decade, and how that builds on these ideas. And then I'm going to talk about this idea of transactivity more. And I'm going to argue that we could think of it as the DNA of a successful collaborative group. And what does that mean? It means it's a pattern. It's an underlying pattern. It replicates itself. It creates a structure around itself in those collaborative groups. And in particular, makes predictions about students, about their collaborative potential that might extend beyond just the context in which you observe first those kinds of interactions. And I'm going to talk a little bit about scaffolding those transactive contributions with accountable talk, because there you'll see some principles for design of technology support to enhance collaborative interactions. But then I'm going to show how it is that it extends also into a more challenging environment in supporting team interactions over a whole course, even if it's a relatively small time course, maybe not 16 weeks, but several weeks of a course where students are working together in a team persistently on something that's bigger than what they would do by themselves. And finally, I'll conclude with some resources to share, because we're really interested in being able to make connections here, to be able to partner with people on ongoing research. We hope that some of what we have to offer, which Joseph has pointed to in his kind introduction, might be of use to people. here. So why do we care about team-based learning in the first place? A lot of students point to their team experiences in classrooms as being some of the least enjoyable, or at least they always complain about certain kinds of things that can go wrong in groups. And I definitely would be the last person to deny that there are challenges in doing group learning well. And nevertheless, it's an important part of education, and especially at Carnegie Mellon in our professional master's programs, they always have a capstone project, which is almost always collaborative. And in fact, we encourage it to be intense so that students will experience those negative aspects of working together, because it's so important for students to learn to deal with those issues before they go out into the workplace. And we're told actually that one reason why employers like to hire students coming out of master's programs at Carnegie Mellon is that they know that those students have had to deal with a very difficult team experience, and that they're going to be mature coming into the workplace and be able to deal with the realities of workplace life. But beyond that training that they get from having to work together, teams can accomplish larger and more complex goals together. And again, to point to some of our professional master's programs at CMU, oftentimes they're sponsored by industry because they're doing work together that's at a quality level that industry, the companies are interested in and find value in. But that would be less likely to be the case if individual students were just doing a project on their own. But we find that students benefit also in their motivation and their learning gains, and that comes out of some of my own prior research, but really the research of many, many others over decades in the area of collaborative learning. I just mentioned about gaining successful workforce skills. So our work in computer-supported collaborative learning has a unique character, or happily for me, becoming less unique. More and more people are starting to do similar kinds of work. But about a decade ago, one of my former PhD students, Rohit Kumar, built first a collaborative environment in collaboration with Jerry Stahl's group, where what we contributed to the environment was support through intelligent conversational agents. So little dialogue systems that could interact in a group, and they were able to do that because it was an online chat room kind of space where each student would sit at their own computer seeing this interface, and their contributions would go through a back-end loop and then be projected back to the whole group. And that kind of architecture allows for a system to sit in there also and participate as though it was another person at their own computer, because they can see all the same events that are reflected back to each student, but can also contribute events to the same loop. And so here we see one instance of this kind of a system where on the left-hand side we see a shared whiteboard space. These are groups of students working together on a design of a power plant in a sophomore thermodynamics course, where they're learning about what are called ranking cycles. And so they're doing work in a simulation environment that they each have running on their own computers. They're doing analyses on their designs and posting it in the shared whiteboard space. And then they're talking in the chat about how they designed their models, the principles behind them, and they're trying to come up with a joint design together. And the computer agent is listening in on this conversation, identifying where certain issues in the design come up, and probing for deeper reasoning about those issues and how they have implications for design, and what are the ways in which those principles lead to trade-offs in the design. So those agents were injecting content into that interaction, but also making it possible to have a richer exchange in exploring the design space. So those conversational interactions appear in the chat just as though those tutor agents were students sitting at their own computer. Now, the takeaway message from this study was really about the benefit that students get from different sources in their learning. Those computer agents in this particular study And in some sense, we've gotten a little bit away from seeing agents playing this role, but it was really the role of scaffolding reasoning, of stepping students through progressions of ideas, specific ideas, and how they relate to one another, which is very much like what an intelligent tutoring system does when it scaffolds the problem-solving process of a student. And there's very much that's similar in the underlying control structure of one of these dialogue agents and a cognitive tutor, in fact. And so you can see it as just another way of delivering the kind of interactions that our intelligent tutoring systems have with students. But what's different here is that that kind of intelligent tutoring style interaction with students is paired with the interaction that students are having with each other. Now, in this study where we evaluated this setup, we had 4 different conditions. It was a 2x2 factorial design where we had students working alone versus in pairs, and we had students working with the support of the agent or not support of the agent. And this design allowed us to tease apart the separate effects of the support of working with another student, working with the agent, or how they came together. And what we found is that students gained about 1 standard deviation or 1 letter grade from the support of the agent, which is consistent with many results in intelligent tutoring, but also they benefited just as much from having a partner student. But they benefited even more when we brought those 2 together. Beyond 1 letter grade improvement, we get 1.25 letter grades improvement from putting them both together. And when we look at what's going on there, what we see is that the kind of benefit that they're getting is different. That from the agent, the focus is on leading students through correct lines of reasoning, but when the students interact with each other, they're exploring the space, they're reaching into another mind, they're exploring their own ideas. And that's a really different kind of support, and it engages the students in different thinking processes. And so since then, we have worked on design principles for these dialogue agents that operate within these social contexts. And so over the past really decade and a half, if you consider the work on developing those conversational agents, even before we started to use them in full force collaboratively, we've done a lot of classroom studies looking at these agents and their design. And that's been over middle school, high school, and college age. We've looked at even urban school districts, as well as more privileged ones. And we've looked at the university level also, top tier universities versus second tier versus community colleges. We've done work in math, science, engineering, and the social sciences. And most recently, we've looked to see what kind of impact this technology could have in massive open online courses. Over this series of studies, we have been exploring different design principles. We started out in that study I just mentioned with the design of agents that we had used for individual learning before that. And so we started just to see, what if we just put those conversational agents in a social context? But since we have focused more and more exclusively on learning in group contexts, we've explored design principles for using those agents primarily to enhance and enrich the interaction between students, rather than positioning them as mainly there for support of individual students' reasoning in the context of those interactions. Now, earlier in this talk, I mentioned the idea of personalization, and referring to kind of one sense of personalization that often comes up in educational research, which is about fine-tuning the interaction between a computer system and an individual student to focus the instruction on exactly what that one student needs. But I mentioned that there's a different idea of personalization, creating an environment for personal interactions that benefits the students most within their group. And I just want to point back to an example that I mentioned in my tutorial. Since these are all online, I'm not going to recount exactly that study or the detail of that study, but I'd like to point out, in case anyone's interested, you can go back and look at that and see how it is that one way of increasing learning, or especially increasing the opportunity for students to get practice on the skills that they need, can come from actually just enhancing the social environment between students so that they feel safe, offering help and also exposing their weaknesses. And then we see how it is that we can provide a more conducive learning environment. And that's one of the design principles, and it's the one I think that shows that a support can look very different from the goal, the learning goal. So we might know that what we want to increase is practice on domain relevant skills for students to spend the time on those things that they actually need the most help with. But instead of designing the agent explicitly to look for those weaknesses and to offer those opportunities, the agent focused on creating a conducive social environment. And in doing so, the students worked better with each other, and those students that had the needs got to have their practice on the skills that they needed the help with, because the environment was conducive for that. And so I'd just like to point to this idea that personalization of instructional opportunities might take on more of a social flavor. Now, I mentioned how it is that our most recent work has come from a foundation laid in classroom research, and we have looked at how that extends and generalizes in massive open online courses. And one of the ideas that came out of some of what we've heard, especially of the local context here in Singapore, is that some of the main concerns are different. And in fact, so in the area of massive open online courses, a huge concern in general has been the large attrition rate. And so one of the things that we have seen is consistently offering these collaborative opportunities to students in a MOOC context reduces their tendency to drop out. And when we've evaluated this, it's always been kind of at a local level. So locally, if we look at over time, the general propensity to drop out, do we see a local effect of a local experience of having interacted collaboratively? And we do see this consistently across the courses where we have deployed these collaborative activities. And you might be saying, okay, but in this context here in Singapore, our students, they're working very hard, they're not dropping out of courses. So how is this relevant for us? And I think that's an excellent question because it is different. And I'm going to talk about what does this actually mean after I sort of step through the result. So you can see here, we ran an evaluation in several different MOOCs. I showed a list of them earlier on my previous slide, but in one of our recent studies, a medicinal chemistry MOOC run out of Davidson College. In this particular setting, we had a nice natural control. It was kind of a natural experiment because these activities were situated within each unit of a course where students would have the opportunity to engage in that reflection activity or not. It was optional at the end of a unit. And so in each time point that provides the data for what is referred to as a survival model. It's a kind of statistical model. It's a type of logistic regression model, almost like a learning curve model. But in this particular case, what we're doing is we're looking at how the experience of time varying properties in a student's history within a course manipulate their probability of dropout from time point to time point. So in every one of those time points, they have the option of clicking on one of these collaborative activities or not, and we get to observe within those interactions, the observed probability of dropout of students. If they did not click, we have a baseline level of probability of dropout that we compare every other situation to. If they clicked, they may or may not have clicked at a time when there was another person available to do that reflection activity with. So if they clicked and there was no partner present, we could then observe the probability of their dropping out by the next time point in those situations. And then similarly, if they clicked and there was another partner student in those situations, what was their probability? And in teasing these kinds of situations apart, what we're able to do is measure the impact of another student being present, because there's nothing in the self-selection that affects whether students had access to a partner student in their reflection. And what we observe that's striking here, that says something to those who are very concerned about dropout per se, but I'm going to tell you what that says also for this Singaporean context as soon as I first highlight the actual results. So what we see here is no difference in probability between the case where a student did not click and the case where a student clicked, but in doing that activity, they did it individually. But if they did it and there was another student present in that interaction, we observe a 70% reduction in probability of dropout by the next time point. Now, that doesn't mean that 70% of students who did one activity completed the whole course. That's not what we're evaluating here. That would have indeed been a great result. It's not what we had, and I don't want that to erroneously be communicated. But what we see here is that locally, the probability of dropout by the next time point is manipulated by that experience of having interacted with another student, and it's a positive impact. It increases their commitment to stay in at least a little bit longer in the course. So what does this actually mean? So on the one hand, we might care about the actual outcome of staying in. If we keep students in a little bit longer, they have the opportunity to be exposed to more of the material. But it says something even if attrition is not particularly your concern, because why is it that it increases students' commitment to a course? They're going to spend their time on what seems worth it to them. And if they are experiencing benefit, they're more likely to stay in. And you can interpret this impact on attrition in a context where students do have the tendency to decide that it's not really worth it for them to continue to be involved. If they stay in a little bit longer, it's showing that they're having the experience of benefit. And that experience of benefit is important, even if the problem of attrition is not particularly a problem that you're worried about. This shows that students feel benefit from their interactions with other students. Okay, so moving along, we see that students benefit from their social connections. This is really similar, I think, to a result that Dragon pointed to yesterday in his talk, where he was looking at the impact of what he was defining as strong ties within a network that can be observed within the discussion in an online course. So I think that that's a very synergistic, similar, indicative finding. But now we want to dig more deeply into this idea of transactivity as the DNA. So this previous result was just interaction at all. Do students appreciate having that interaction with other students, regardless of what we find in that interaction? But now we're zooming in and we're looking at the how is that interaction between students actually working. Now, transactivity, we've already defined as a property of discourse, and we didn't define or didn't come up with that idea by ourselves. It actually grows out of originally a Piagetian view of learning, and it came from ideas that were around at least since the 60s. I think even before that, I think the 60s are when these ideas were translated into English, but they were around even before that. And it's this idea of students being more open to changing their mental models in an environment in which they both take their own ideas seriously, but they also take the external stimuli that they're exposed to seriously enough that they allow it to challenge their own reasoning. And in that environment in which there's a balance, they can experience a cognitive conflict, and that cognitive conflict triggers a search for a new explanation that can lead them to come to enhanced learning within a learning experience. Now, there are many theories of learning, and Piaget is not the be-all and end-all of learning theories. There may be even nobody in this room who particularly subscribes to his learning theory, but interestingly, if you trace the idea of how transactivity came to be associated with an evidence of an opportunity to experience a cognitive conflict within this learning theory, and then you look across different theories of learning and correspondingly how those have been operationalized within paired discourse analytic frameworks within those learning theories, we see that actually the same pattern, the idea of the value of expressed reasoning in building reasoning on reasoning, shows up in virtually every framework about what's important about collaborative learning. It can be called different things, it can be justified in different ways, and yet it's probably the most popular, most frequent kind of discourse pattern that's valued in collaborative contexts. And it's not only in our own research where we see correlations between the prevalence of transactive moves called as transactive or called something else and learning, but in other people's research as well, we see both mediating and moderating effects across studies. It's well substantiated. And also, similar to what's valued in other areas, even organizational communication, we find that this idea of expressed transactivity being a way of creating an environment in which you can disagree while maintaining the solidarity of your colleagues. And so it's been investigated also in organizational contexts and in a variety of other kinds of context as well. So I think it can be of interest, not just in learning sciences, but also in the social sciences more generally. But we find, actually, this doesn't, transactivity is not the norm. It's not the norm of how students or even colleagues work together. I mean, any of us who frequent faculty meetings probably wish that people were that respectful towards each other's ideas as a norm, but it doesn't always happen. We don't all have impeccable social skills. We're still working on those. It's rare that we find a high concentration of transactivity in collaborative interactions without support. And that's why it's so important to do research in this area. We know that this is a valued process. We know that it predicts learning, but it's not the norm. It's not what happens without support. So how can we scaffold that? And that's where I would go back to my partnership also with Lauren Resnick that I mentioned earlier. Interestingly, when we came together to do our work, we were coming from very different areas of research. She had mainly done her work in the classroom discourse community, where the focus really has been on what should teachers do that does things like build student identity as active reasoners, that increases learning, that increases richness in interaction, but they weren't thinking in particular about the discourse moves of students or how that relates to student learning. That comes from a different community, one that I have been part of, the collaborative learning research community. And it was very interesting to us how it is that there was kind of this really natural, almost total pairing between findings when the focus was on teacher moves, and in her case, calling those facilitation moves accountable talk moves. But again, there are many different frameworks that have been proposed by different researchers in different countries about what kind of facilitation gets active engagement of students and increased learning gains. And internationally, and this comes out of a book on socializing intelligence that Lauren Resnick and a couple of her very esteemed previous postdocs have published through AERA Press, I think in the past year, where they look at accountable talk formally, but also other work in classroom discourse and what are the findings. And what we found in our research is an almost perfect pairing between what, and I'm going to show you what these look like, accountable talk facilitation moves and forms of transactivity that come from the original formulation of 18 different transacts from Berkowitz and Gibbs from the early 80s. So here we see an example of a teacher in a classroom using accountable talk, and you don't have time in this lecture to read this whole interaction, but the idea here, I'm going to point out those key aspects of what it is that this teacher is doing. What they're not doing is getting into the substance of what the students are contributing. Instead, what they're doing is prompting for kinds of responses, asking students to elaborate, asking them to agree or disagree with one another, pressing for more reasoning, asking them to say more, or summarizing what they're seeing from multiple perspectives, reformulating it and saying, here are how I see ideas in this interaction coming together. And we call that a revoicing move, but it's really a summarization and refocusing move that focuses on how ideas relate to each other that are expressed by students. And these moves, as used by teachers, are supposed to place student reasoning at center stage, to encourage students to think of themselves as active reasoners, as sources of reasoning. And we talked about that source versus recipient of reasoning idea in my tutorial also from earlier in this week, and you can go back and look at those ideas. And this idea of accountable talk really comes out of a movement that tries to place students in that role as a source. And so we can see here what it is that the teacher is doing, how the teacher is positioning students in this way, and that in this interaction is the primary goal of what the teacher is doing. Not that teachers in these classrooms never lecture, or that lecturing is bad, or that the teacher isn't in fact a source of some unique knowledge that the students need to have. But in these interactions, the goal is not to impart that knowledge, but to get students to realize that they have something and that they can offer it to each other, teaching them how to learn from each other, how to use each other as resources, how to be student resources for each other. Because the idea here is that personalization isn't always about some external source imparting something to students. But when they're out in the world, when they're out on the playground, when they're in their jobs, and the teacher's not there anymore, can they learn on their own? Can they learn together? Can they use the resources around them? And this teaches them that they're reasoners in a community of reasoners that are resources for them, that we can scale without losing that personal touch if they see themselves as being part of a community. Oh, and here's the citation for that book I just mentioned. And you can see that in this book, we see study after study that highlights how important this kind of interaction in classroom context is for increasing achievement on standardized tests, for leading to retention from year to year, and transfer even across domains, and even impact on reasoning skills in general. So our work, the work that Lauren and I did collaboratively, as I mentioned, was in an urban school district. We focused on 9th grade biology, but we expanded into math in the later years, and we were looking at pairing what Lauren was working on, which was teaching teachers how to use this accountable talk with their classes. And what my group was doing was injecting these collaborative learning activities where the computer agents, the agent support, the scaffolding for the interaction was actually using as a design pattern accountable talk, what we just saw that teachers should be doing in these accountable talk classrooms. So similar to that first interface that you saw earlier in the talk, here the computer agents were manipulating what's being displayed in the shared whiteboard space to scaffold the activities that the students were doing collaboratively. And in this case, they were exploring cell models to understand how diffusion works. But the agent's contribution to the chat was using these accountable talk loops. And here we see an agent using this revoicing loop that we just mentioned, that teachers also use. And so over a series of studies, we consistently saw that accountable talk computer agents led to enhanced learning gains and also contributed towards students participating more actively in the teacher-led whole class discussions that followed those. But now I want to move towards a more challenging idea. Can we build support for persistent team interactions in online courses? So not just a short-term, one intensive interaction between a small group of students where they come in, talk to each other about some concept, and then move on, but can we actually support them in these more consequential team-based interactions that occur over a whole course? And here I'm going to talk about preparation for one course offered by the Smithsonian Institute. That's a national organization in the United States that actually runs some major resources, these big, great museums that I highly recommend that you take advantage of if you visit the United States. But you might say, okay, yeah, but here, what you're going to talk about today is more recreational, but we're working actually on being able to deploy this in some capstone contexts, which I think is actually the ultimate test of can we support effective team interactions. And here I'm going to show how it is that different from what we had done in our previous studies where we were scaffolding interaction within these short-term, intensive, synchronous, collaborative interactions. What we want to do now is use transactivity that we observe as a basis for measuring collaborative potential so that we can use it for team formation. Because what we find is actually student teams in online courses are failing from the beginning. That's a big problem. And if we don't address that problem that sets the stage for the ongoing teamwork, whatever we do to try to support the interaction is going to have much less impact because those teams are not set up in the beginning for success. So there are challenges for teamwork in these online courses. We see challenges, and we're going to focus on the problem of selecting students to work together, but then monitoring team processes is also a challenge, and supporting team processes also a challenge. And as the scale increases, these problems are bigger and bigger. But if we can use technology, we can scale up our ability to address these problems. So let me start by talking about the problem. We were very lucky to be able to partner with NovoEd, which was a platform for online courses that was kind of a forerunner in the area of team-based MOOCs. But you know, they saw the value in these team-based MOOCs, but they you know, were really sort of, because they put themselves out there, the ones that really saw the challenges. And in the data that they were very kind to share with us, what we saw is that from 177 teams across 2 courses of data that we had, 87% of these teams failed. They failed at finding and keeping team members. They failed at getting discussions going in the first place or keeping their teams active. And we did find that there was a positive impact on teams having somebody who took an active leadership role, but that impact was big in the teams that had them, but there were very few teams that had an active leader, and that we just really got a strong sense from this data that you know, just focusing on fixing a team after it formed was not going to give us the impact we wanted, but we had to fix that initial problem. We had to set up teams for success. So again, we come back to this idea of transactivity and the pairing between cognitive and social factors that I've already talked about. I talked about the fact that students will behave more transactively with students that they respect and feel safe with. So if we see students behaving transactively more with some students than others, we can use that as a read of the social dynamics between those students, that's a pair of students that trust and respect one another. And if we want to place our teams in the best potential for working well together, then we're going to put people into teams where each student is going to perform at their best. And this is what we were trying to do. So oftentimes in these original Noble Ed courses, the team-based massive open online courses, students would come in and they were responsible to find teammates for a project that they designed, and then that would work within their teams for the remainder of the semester. And what we did was we changed this paradigm so that first, students would come into a course, they would build up some individual expertise. They would share that in the context of the whole community. And based on that community interaction, we would pair students in groups that we saw collaborative potential between the students, and then the students in those groups would work together. And so we developed this automated transactivity-based team formation process, and it had two technical components. One of them was the automated analysis of transactivity that would allow us for each pair of students, based on their interaction within the whole class discussion forum, a measure of collaborative potential, but also an approximate constraint satisfaction algorithm that could, across an entire course, assign students into teams in such a way that students were with the other students that we had measured that they had the highest collaborative potential with. If we did an exhaustive search, it could take a year to assign students to teams, but with this approximate constraint satisfaction algorithm, a minimal cost network flow algorithm, a very, very common approximate constraint algorithm paradigm, we were able to do it very quickly and assign students to teams where we see that we are actually having success maximizing the criteria, those constraints that we place on the groups. And in our lab studies, you'll see, I'm going to talk in detail about one of them, but we did a series of these. We both maximize the collaborative potential, but we also kind of maximize the diversity and expertise within those groups. And then in our actual deployment, we focused entirely on maximizing the collaborative potential. I just want to highlight that this was a place for a big win in the area of deep learning. There was a deep learning tutorial on the first day, and some of you were probably exposed to ideas in deep learning for the first time. And normally we have a huge actual concern in the field about deep learning that it might be just memorizing very complex patterns and that it might actually reduce generalization. But in this particular case, we applied it to the problem of being able to identify transactive contributions, and we were able to leverage another task, an analogous task, a big popular task in the field of natural language processing called entailment detection, to build a network that is highly effective at seeing ideas that are related to one another at an inference level, not that we're seeing similarity, but that we're seeing connection at an inference level across a wide variety of domains with an existing very large data set, and that we can then adapt that learned network to the problem of transactivity detection with a very small domain-specific transactivity annotated data set. And then what we found, very surprisingly to us, was not only was that highly effective at being able to detect transactive contributions within the domain area, in the case of our experiment, looking at data that's talking about environmental issues, then we applied it to a separate corpus in a completely different domain where people are talking about evaluating ideas for superheroes. And it was just as effective in the corresponding domain. And in our previous work with automated transactivity detection, we had models that were accurate within single domains, but failed almost entirely to generalize to new domains. And the reason was because of the lack of ability to evaluate how ideas across domains are related to one another. But this was a really interesting application of a pre-training task in deep learning to a huge corpus where we gain the ability to have representations that can see these connections. And anyone who knows me knows I've been a skeptic of the whole deep learning thing because I was a neural net person in the 80s, and to me it's like, yeah, that again. Yeah, deep learning, really, okay. But in this particular case, I was really surprised. So anyway, I wanted to throw that in as a bone for those technical people in the audience who are less interested in the learning sciences findings. that this talk largely focuses on. Okay, coming back to the main thread in my talk, we wanted to be able to evaluate this paradigm for team formation first in lab studies. So before we would subject students in a real online course to our technology. And so we made a fake massive open online course that we ran in an environment called Amazon Mechanical Turk, where we can get lots of human subjects. And so we ran batches of people through this simulated massive open online course. And in some batches, we randomly assigned people to teams. Random, except that we made sure that there were students from each of the 4 areas of expertise on each team, with batches where we did the transactivity maximization to assign teams, and also with the constraint that we wanted to have teams of each of the 4 kinds of expertise. And the project that the students were doing in our fake course was to work together on a proposal for an energy plan for a city, where they had to negotiate over 4 different plans that we would offer them, that none of which were perfect, and all of which had trade-offs that brought in the expertise of the 4 students. And so it's a good knowledge integration task, and it really tests the ability of the group to reason together and to produce an integrated product. So we had 4 different perspectives from 4 different sources of energy coming together, and what we measured as success was evidence within their group product of knowledge integration across the 4 perspectives, but we would also look for that evidence of transactivity in their discussion as they were working together. So as I mentioned, we ran batches of students through this fake online course where they would take a pre-test. They would learn something about one energy. They would write their own individual proposal, and then they would go to a discussion forum where they would post their proposal and discuss it with the other students. And in that context, they gave each other feedback on their proposals. And so students would have something to offer to some other students, because each student was only taught their one energy perspective, but within that discussion, other perspectives were represented. And so we could see the nature of the feedback that students were given, and we would measure the extent to which that feedback was transactive or not. And then we used that to assign the students to teams. They would work together either in their randomly assigned teams or their transactivity maximized teams to produce an integrated product, and then we would look at the quality of that product, and in some of our pilots also learning about integration of ideas. So in the discussion forum, you can see where they would discuss their ideas, and this is about the scope of the amount of text that they were offering to evaluate each other's ideas, and we looked to see if they were transactive or not, and we used that to assign them to their teams, and then they would interact through chat. It would be structured by a conversational agent, and they would work together in a shared text editor to produce their collaborative product. And so what we found was that in the transactivity maximization teams, we saw more evidence of transactive exchange, but we also saw more integrated product. And in further studies, we saw that in a public context, students give each other better feedback, and they also benefit from the feedback that they see other students getting, and it better prepares them then for their subsequent work, which indicates that they're learning something from observing the feedback that other students are getting. But we find that if we want to look, do students actually learn to integrate ideas better from having experienced a more intensive a collaboration? What we find actually is it doesn't actually lead them to learn more about how to do knowledge integration just because they experienced better knowledge integration in those teams, that we have to use the explicit scaffolding for the transactivity to show them that that's the norm, that that's what we want, that that's what good collaboration means. So that's just summary of some additional studies. We took this paradigm, we deployed it in an actual MOOC. I mentioned the Smithsonian Institute. They had created a course about superheroes, but it wasn't just a frivolous course. It was a course about history and how the genre of a superhero is a lens through which you can understand how, during a period of time, people are dealing with their fears about issues that are going on in their society at that time. And in 3 different earlier deployments of this MOOC before the team-based version, people had created their own superhero. And in this new collaborative version, students from the 3 earlier deployments were invited to participate and work together to design superhero teams to address larger societal issues. And so in this 3-week course, they came in, they posted their individual work on the superhero they designed from the earlier deployment. Based on that interaction, we automatically detected the transactivity in the discussion forum and assigned students to teams. And then in their teams, they worked on their superhero team to address a larger societal issue. Now, there wasn't an experimental manipulation in this study, but we found correlational results that were consistent with our findings from our pilot studies. So the measured potential, collaboration potential from the whole class discussion forum predicted number of transactive exchanges that we saw in the recorded collaborative discussions that the students had. Also, in terms of the number of students who were not slackers within their group, and also on the interaction that we see in the superheroes in the joint story that shows an integration across the creative work of each of the individual students coming into the course. So let's just conclude with reminding you of some resources that Joseph actually already mentioned. I want to mention that in our dance community, we also have a monthly online talk series where we invite speakers from all over. We'd love to have some local speakers, but it's also an opportunity to hear from other people in the area of supporting learning in social contexts and online courses. But we also have tools that can be used to build your own collaborative environments and deploy studies like the ones that we have done. And this includes a discussion forum where you can integrate interventions like social recommendation. We have our light side tool bench, which I talked about briefly in my tutorial. Also the social recommendation code itself, data infrastructure for discourse, and also the agents for conversational support in collaborative activities. And all of these resources are open source. The entries on the resources page point to our GitHub repositories and also to instructional materials so that you can learn how to use them. So in conclusion, don't forget about social factors in learning. Transactivity is one key construct for understanding how to make effective collaboration work. Technology can leverage this idea both in terms of automated analysis that can make use of the recent developments in language technologies and machine learning, and it can be used to structure an environment in order to encourage productive interactions for learning. So I think that these results really just scratch the surface. There are still big problems and issues. It's an active area of research, and we'd like you to join with us in collaboration. So let me know if you're interested in partnering with us, and or even if you don't want to work with us particularly, make use of the resources because they're there and we're happy to share them. So thank you so much for giving me this opportunity.